Hello. Right, slightly delayed video due to accumulation of breakdowns over the Christmas holiday and things like that, and me losing my voice for a bit. But Pendulum Part 3. Since the last one, I've refined the circuit slightly and added effectively a constant current limiter, which should make it independent of battery voltage. So the amplitude doesn't change, or the power to the pendulum doesn't change as the battery goes down, as long as you use a suitable value resistor here to set the current. And I did a little PCB for it. Unfortunately, it didn't work, or rather, it didn't work as expected. And it took me a bit of thinking about it and examining the system to figure out why. Let me just stop this for a minute now. Now you can see this is now running stably before I stop it. It's not taken off and started banging against the coil like the previous version did. My idea with this was to put a variable timer on it, something as I mentioned is a possibility. You can vary the pulse length using the preset over quite a wide range, about a 10-to-1 range, which is that preset there. And I expected that to stabilise it, but it didn't. If I stop this now, I'll show you why. The electronic trigger working off the coil, which is that bit there, the comparator, and pick up from the coil, that triggers exactly as the magnet passes through the dead centre of the coil. And that's when the pulse starts. The problem is, when the magnet's dead centre, it's being repelled from the coil when the pulse fires, but there's no directional content to that. It's just being repelled where it is. You get most motion or impetus added when the magnet's actually about halfway out of the coil. So it's got the maximum repulsion from that end of the coil's repelling that end of the magnet, this end of the coil's repelling this end of the magnet, so you get maximum effect somewhere around halfway out of the thing, either side. With the pulse starting dead centre, if it's putting enough power in to keep it running in one position, as soon as if it accelerates at all, or, the motion, obviously the swing rate is constant on a pendulum, but when it's doing a small swing, it's moving fairly slowly. When it's doing a big arc, it's moving fast. The faster it moves, the further it's got out of the coil before the pulse ends, so the more energy it picks up. And if the swing's not big enough and it's not picking up quite enough energy to keep it running, then the swing lessens and it picks up even less energy because it's getting nearer and nearer to that centre point where it's got no directional repulsion at all. So that's the original first rough prototype. So a bit of hacking on this and adding some extra components, which I've not drawn a formal circuit out for yet, but that's the concept. If you excuse the scribbles. The bulk of the circuit, all the comparator and everything is the same. But what happens now is it sets up, when it triggers, it sets a bistable latch, flip-flop. That effectively starts a timer here with another preset resistor and capacitor before it triggers the monostable that fires the output pulse, which has its, again, variable time. Once that triggers and the monostable's actually started the pulse, so it's self-latching, it then resets the bistable. So that can be anything from about 10 milliseconds to 100 milliseconds with the values time, or was it 10? Yeah, roughly something like that. I can't remember the exact time down, but it's an adjustable delay. It could be made longer easily just with changing the capacitor. And that gives a delay before the pulse starts. So if it's set so the pulse starts at about the magnet halfway out on the ideal swing either way, then if the swing gets too wide, the magnet's moving too fast, it's already got past the sweet spot in the positioning before the pulse finishes, so it doesn't pick up as much energy. Whereas if it's nearer to the ideal spot, it picks up more energy. So it can't self-start completely, but once it's going at approximately the right swing, it will stabilise and keep running at the same amplitude, as long as you have the adjustments right. So that's, I'll do a formal circuit for that as well. It's got one or two other bits in it. Oh yeah, I've removed the requirement for the battery centre tap, so it can run on 3 cells or a lithium cell or whatever. It's just got an extra resistor to ground there to give it a centre point between that one and that one. It means it's taking about 1.5 microamps from each side of the supply, or it would be. So it's taking a fraction more power overall, but the CMOS consumption and the comparator consumption is so small, I think it's completely irrelevant compared to the power to the coil, which is quite a few milliamps. I didn't actually start that quite wide enough. So it's got to be started into the range where it runs at the correct amplitude, and then once it's there, it'll self-regulate. So that's the updated concept, and I'll probably also do an updated circuit board for it, with that second delay, or the additional delay as well as the pulse duration, so it can be adapted to other things. Now, the other modification I've done on this is based on something I saw on the Tested channel, and I was reviewing a pretend perpetual motion machine that has a ball running down a track and firing itself back up into a collector repeatedly. I'll add a link to that. That used a inductive proximity switch and fired a large solenoid coil through a magnet. I thought, this thing, you could do similar things if you separated the trigger coil and the power coil. So that's why it's got 2 connectors on here. There's a little jumper ring. If you take that off, then the trigger and power are separated. So one connector feeds the trigger, the other connector feeds the drive power to the coil. So that theoretically could operate things that have separate sensor and power. You could use the same kind of reluctant sensor technique with a biased coil, magnet biased coil, to pick up a moving piece of metal, or you could just have a moving magnet that will be picked up directly by a coil and then given a kick by another coil at a suitable, delay or power. So anyway, that's the state of that one. I've also got quite a few other projects backlogged that I've been working on when I couldn't speak sensibly to make videos. I was croaking too much. So there's quite a few more to come fairly soon, hopefully. Anyway, hope that's of interest, and thanks for watching.